So we've got a 2,000 kilogram car, and it accelerates from 0 to 60 miles per hour in 12.3 seconds. That's kind of like an average car. Well, an average car, yeah. All right, and what net force is applied to the car? So given, got a flat level ground. Let's say this is a 1957 Volkswagen Beetle. All right. And so its initial velocity is 0, and then at some distance away, its final velocity is 60 miles per hour. Okay. And this took 12.3 seconds. And we want to find the net force. I just love it when I record a video on one of these. Kind of I can't wait. Okay, so now, so we want to know what is the net force. So let's start. I usually try to start my work with what I'm trying to find. Like I know that the net force is equal to the mass of the car times its acceleration. So what does this tell me to do? Well, I know what the mass of the car is, but I need to find its acceleration. And when I'm looking at this, what I'm given, okay, I'm given velocity and times. I can probably solve for it. But this is bad. Miles per hour. We have to convert it because we have to do everything in meters per second. So 60 miles per hour. The conversion is, well, I asked Siri, and Siri told me that 1 mile per hour was equal to 0.447 meters per second. And when you multiply that out, you get about, 28 or something? What do you get?
26.8, so 27.
26.8? 26.8. You could use 27, that's fine. 82 meters per second. We'll just keep a few more digits than we really need. So now what have I got? I've got initial velocity, final velocity, time, and I want acceleration. So which kinematic equation has those four things in it?
Velocity equals v naught plus acceleration times time.
And we're going to assume constant acceleration here. That's probably pretty close. All right, it's not bad. So the acceleration is equal to the final velocity minus the initial velocity. That's really delta v divided by delta t. Right? That's the definition of acceleration, is the change in velocity over the change in time. So this is 26.82 meters per second minus 0. We're going to divide that by 12.3 seconds. So what is my acceleration?
2.2 meters per second.
What is it?
2.2 meters per second.
Oh, that is bad. 2.2. 2.18.
1.8, but you guys need to chill.
Yeah, we'll go 2.18 meters per second squared, just to irritate Grant. And then now we know what the acceleration is. It's easy to figure out the net force. The net force will be 2,000 kilograms. We have to accelerate that much mass at a rate of 2.18 meters per second squared. And so what do you get? 4,361 newtons. Or you can round it off to 4,400 newtons. Yep.
That's not accurate though. Yes, it is.
Yeah, but you don't really have enough information more than about 2 or 3 significant figures. So this 1 is totally meaningless. This 6 maybe maybe. So let's go ahead and round it off. 4,360 newtons. That's what I would round it up to. Okay. So now the big picture of this problem, let me zoom out a little bit so you can see the whole thing. Okay, so the big picture is this. If you have an object and you're given kinematic information so that you can figure out what the acceleration is, you can figure out what the net force has to be. So like I think a previous starter problem, we did just the opposite. I gave you the net force, you had to figure out the acceleration, and then you had to solve a kinematics problem with that acceleration. But you can go the other way. I can give you kinematic information that allows you to solve for acceleration, which allows you to solve for the force, the net force acting on the object. Any questions? That is all.